Should be good.
All right. So are you ready? Okay, all right, let's start. So thank you for joining. This is our webinar about fully automated deployments with ArgoCD. And it will be presented by me, Diana, and Ricardo, working in the Kubernetes team at CERN. So let's start with our motivation. So why do we want to have automated deployments? And the reason for this is we would like to have our infrastructure as code. This would mean we can iterate over different versions. We can see what exactly is running and where. And of course, this will mean we have to perform less manual steps, and this will decrease the likelihood of having human errors. And last but not least, of course, let's automate our jobs before ChatGPT does it for us. What exactly we want to achieve? So we want to have automated provisioning of clusters. Because we have the clusters as code, we will have methods of actually provisioning them when we need. Then we'll have ways of automating the deployments of applications and the services on those clusters. But because we have a multi-cluster setup, we need a way to centralize the monitoring effort. But once we have this in place, we can leverage on the multi-cluster approach and replace clusters instead of upgrade. And what this means is, as you can see in this image, if you have two clusters of 122 version and a load balancer that sends traffic to those clusters, when you want to have a newer version, you can just create a new cluster because it should be easy. You can provision them and you can deploy applications easily. And then you just send a small part of your traffic to the new version. And when you are confident enough, you can start decommissioning the older versions. So this is how we would like to do it. And I will spend a second here if someone wants to try and spot vectors in our automation journey. And if someone wants to speak up because they know what this is all about, let us know. All right, I think we can move on. So how we actually want to do it is we want to use ArgoCD, we want to use Vault, we want to use Thanos, and we want to use Argo workflows. And the way what we want to do this is described in this repository here, which is called ArgoCD 101. And you can try and follow everything up as well, everything that we'll present in the demo that follows. So ArgoCD, this is our first actor in our how we want to do it. So ArgoCD, probably most of you know, but just in case, ArgoCD is a Kubernetes controller that continuously checks if the state of things that are running on the clusters are in sync with what is stored declaratively somewhere, and tries to make changes in order to get to this desired state. What is interesting about ArgoCD is that ArgoCD can be managed using ArgoCD. And this is a very cool feature. Of course, you have to deploy ArgoCD somehow, and you cannot do it if you don't have it running. So for now, we deploy this as a Helm chart manually, but it can be part of some kind of greater way of automating everything. For now, this is a manual step. But once you have ArgoCD up and running, you can deploy an Argo application, and it will see that, okay, I have everything running, so I'm not going to redeploy, but I'm going to pick them up and say I'm healthy and synced. If not, you'll have some debugging to do, but it should work either way. And second point here is we decide what applications to be deployed on what clusters using ArgoCD cluster labels and selectors. So what this means is we have labels at the ArgoCD level. So this is not at the Kubernetes level. Internally, ArgoCD stores the clusters as secrets on the cluster. And when you say label, you put actually a label on the secret. But we are going to use the higher vision of this from ArgoCD perspective. And you can actually label clusters from the graphical interface as well as the CLI. And what this allows you is, it allows you to have an application set where you say, please deploy this on all clusters, or please deploy this only on the clusters that have these labels, or don't deploy this on clusters that have these labels. And this allows us to provision clusters and then automatically deploy our add-ons, our dependencies, and our applications in a very convenient way. ArgoCD plus Vault. This cute bag is Vault. And what I want to spend more time here is actually how Vault is integrated with ArgoCD. In case someone doesn't know, Vault is a solution in order to keep sensitive data, and you can find a lot of information upstream, but also in our demo repository, we explain how to easily deploy, unseal, and add some test values. I want to spend more time on ArgoCD here, so we can create a plugin. It will run as a sidecar to Argo repo server pod. And what it will be doing, it will actually replace the path that we will store on Git with actual sensitive data. What ArgoCD actually does, it never does Helm install, it does Helm template, and it gets the manifests and then applies them. And what you can do with a plugin, you can pipe the result from Helm template into a binary that understands how to go into Vault, get secret value, populate the manifests, and then they will be applied. How this looks like, it looks like this. So this is what you would store in Git. You'll store just the path to a secret in Vault. And this just will work in an automatic way. Also to mention here that we use the plugin for Vault, but you can also use it for different ways if you need to personalize somehow the init command in ArgoCD. For example, maybe you need variable or you need a certain flag for Helm template. This can be the way to go. Argo workflows. So Argo workflows is actually useful for everything that can be defined as a workflow. And we use it to provision clusters, because with clusters, it's very clear. You say, create the cluster, and then you can add a node group. You can register the cluster in ArgoCD or somewhere else as needed. So the steps are very clear. And with Argo workflows, it's very easy to track. It has a nice graphical interface that shows you with green if everything is working, or with red, and shows you the logs, errors, and everything else. What we store as code is the cluster template, the flavor, the node groups, the regions, the zones, everything. And as a result, we can easily create and recreate clusters when needed. Of course, because Argo workflows is good for everything that can be defined as workflow, it's kind of very general, and we might replace this with a more focused solution in the future, like Crossplane. Then we have Thanos. So Thanos is an open source project that allows us to centralize our Prometheus. And why do we need this? Because we have many clusters and we want to monitor them in somehow centralized way. And it gives you a single global query view where you can just tap your search query and it will give you answers from all the clusters. And it's very easy to have metrics retentions and back up your metrics in a bucket. And in the corner here, you can see Thanos, of course, and you can see Prometheus in the bottom corner. The architecture looks kind of big and messy, but I thought it's important to put it here just to show you how we are deploying this. So we have the Thanos service and the Thanos sidecar. The Thanos service should be running on the, let's say, main cluster or main observability cluster, and it consists of a lot of smaller services. It's this Thanos query frontend, which has some caching and query splitting. Thanos store gateway that knows how to communicate with a bucket. Thanos compactor and Thanos ruler if you need alerts. So this is what will be running on our main cluster where ArgoCD is also running. But also from another perspective, we have a Thanos sidecar, which is a sidecar to Prometheus and will be running on all our clusters that have different purposes than just being a central cluster or monitoring. So if you have an application dedicated to ML and you need to monitor the clusters, which you absolutely need, then you just deploy the Thanos sidecar and your metrics are stored in a bucket and you can do amazing things with them. And the same thing, but with easier to track image. So you can see in the observability cluster, we have a store, we have a query, and we have Grafana and Prometheus. And then on all other clusters, we have Prometheus and Thanos as a sidecar to Prometheus. And of course, we have a bucket where we can store all the metrics and then just query historical data the same way we query all the data. Thanos service is deployed on our, let's call it main cluster for this demo. And Thanos sidecar is installed on all desired clusters using this label, which is an ArgoCD label that I mentioned before. And it's called monTrue because it's monitoring true. And this is because Thanos sidecar is a part of Prometheus stack. So when you deploy it, you actually deploy Prometheus and Thanos as a sidecar, and also you have Grafana if you want. This is something that you can actually change. And we are approaching demo time. So I just wanted to spend a minute to discuss the structure of the repository. So we have the add-on Thanos, where you can have all that is necessary to deploy the Thanos sidecar. Then we have app, which is the ArgoCD applications. And we have this convention of calling them add-on or service, just to be easier to track. And you can see that we have service ArgoCD, which is an ArgoCD application that manages Argo itself, but something that I mentioned before. Then we have clusters where we store the configuration for clusters and the workflows to provision them. And we have services where we store ArgoCD, Thanos, Vault, and workflows Helm charts to easily deploy. And again, the demo repository if you want to try the demo yourself. And with this, my slides are over, and we can go to the demo time.
All right.
Thank you.
Turn on the video. Thanks, Diana. So I'll share my screen here and hopefully this will work. All right, can you see my screen?
Yes.
Awesome. So one thing that I wanted to mention here before we start is that these components, so in this demo, for the demo, I will use this 101 ArgoCD repo. So this is kind of a test, similar to what we had in a couple of years ago with GitOps getting started in Flux. The components are just examples. For example, we use Thanos here because it's an easy way with Prometheus stack to kind of aggregate without having to deploy any additional components. But if you would deploy this in a service in CERN IT or at CERN, you would probably be looking at the new monitoring system that is being deployed based on Prometheus. So basically, this is all Prometheus. So it doesn't really matter if it would be Thanos or another component. For us, it's just easier to develop a demo with this. So for this demo, I'll go first quickly through this repository. So as Diana mentioned, we have a central cluster that hosts the core, what we call the core services. So this core services are ArgoCD. The second one is Vault for the secrets. And again, this is our instance of Vault for this demo. But once we have a Vault service in CERN IT, we could rely on that as an external service. And the third one is, again, Thanos. That could be obviously a central monitoring solution as well. There is still some benefit to kind of, if you have multiple clusters for your service or multiple services, you can aggregate everything in a single Prometheus instance, be Thanos, and then forward to the central monit from a central place instead of registering every single cluster, since especially if you're creating and deleting clusters quite often. And the third component, the other components are workflows. For workflows is Argo workflows. And in this specific case, we are using it for for creating clusters, but we internally we use it for a lot more things as well. So if you look at this repo, you will see the steps that you need to do to bootstrap your own setup. I still need to review a bit the instructions, but if you want, you can give it a go. And then basically we'll create a central cluster that will host first Vault. Then you will deploy ArgoCD with configuration to talk to that Vault. And then finally you deploy all the applications that will basically create everything else automatically. So if there are no questions until now, I would continue. But again, feel free to stop us at any moment if you have questions or doubts about what was just described. Raise your hand or just go for it. All right, I'll get going, but feel free to stop me at any moment. So if we look at Argo, so basically this is the central cluster we just discussed. We have the Argo instance here, and basically what we are deploying there, you will see here. The first thing that we deploy is this main. So main is basically deploying two applications. One is called clusters, the other one is called apps. So clusters is the directory where we keep all the definitions of all the clusters that we want to host. And in the cluster, as Diana showed, we have the usual parameters that you pass at cluster creation, and you have these additional labels that are basically the function of the cluster. And this will select the applications that should be running there. So you can imagine running like 5, 6 clusters or 3 or whatever, and then you can dynamically assign and reassign applications to the different clusters if you would need. And then you can add some new ones. And as long as you put here the appropriate labels, they will get those applications automatically. The second part is this apps directory. So in this app directory, we have all the applications that we want to run in the cluster. So here we separate the applications into 2 types. One is add-ons. Add-ons are in principle to be run on every single cluster. And you can see here the example for Thanos that basically is deploying the Thanos sidecars in each cluster. And then for each application, we have a different file as well. So there's the Thanos central server that does the scraping of the target clusters. There's the workflows application. Basically, it's deploying Argo workflows. And then there is ArgoCD. So we actually manage Argo with Argo. You can do this after the bootstrapping. And finally, a real application. So in addition to these core central services, this is an example of an application. You can see it's actually hosted in a different repo. And you can put here which clusters it should be deployed. So basically here is where the matchmaking is being done. I set it, this is an ML app. So I set it ML true, which means every cluster that has this label will have an instance of this application running. And I think that's it for the description. And then this is the apps directory. And then the reference from each application is for other services. So the core central ones are all in this directory here, serve. So you have Argo, Thanos, Vault itself, and workflows. And each of them inside will have its own configuration. And the similar for the add-ons. In this case, we only have one, which is the Thanos sidecar. And you can see again the configuration, including the things that, no, not Thanos. Okay, it's. I just wanted to show, including the placeholders that Diana mentioned for the Vault keys. So basically, I wanted to show here, this is not really anything fancy. Basically, instead of doing a Helm install, Argo is instead doing a Helm template to generate the YAML and piping that through a plugin that goes to Vault and asks for the data. So in this case, I have like these two keys, but if you go to Vault, so if I log in quickly here to my Vault instance, to the pod, I can query any key value. So in this case, I'm querying this one here. And if you want to add a new one, you actually need to, if you're changing the existing key, you need to patch it. So let's say foo3 equals bar. And if we get it, we see it here now, the 3. One thing to make sure is that actually, if I do put instead it's actually overriding the values that were there. So you need to be careful with this. It's a common error to lose data in the system. And basically,
and I wanted to mention here that the path, if you can go back to the vault, the path doesn't, when you do patch or put, the path doesn't have data, but then when you check the secret path, you have data appended. This is how Vault does it for some reason. So this is something to keep in mind, because it can get confusing and the application might not work. This might be the reason.
Yeah. And in this case, we don't have any kind of authentication because the Vault service is running in the cluster itself. So it's just a token in Vault and the endpoint is available. So you need to generate a token and pass it to Argo. But if you would use an external Vault, you could use any sort of like IDC or any kind of authentication you would decide to use. Alrighty. So again, feel free to stop us if there are questions. Otherwise, I move on to how this looks. So for those,
I have actually one question about Vault.
Yeah,
with the Vault, how are the values populated to applications? Is Vault creating secrets inside Kubernetes, or is it injecting values to pods, or how does it work?
So that's a very good question. So if we go back here, I can actually show you what the configuration looks like by going here. It is here, no? I don't have this. Can you remind me where the command is, Diana?
The generate, it's.
I can also do this.
It's a CMP.
Yeah. All right. So the magic is here. So by default, when you use Argo with Helm, it would do a like if you use Helm, it would do a Helm install. That's not how Argo does it. It actually does a Helm template, and it generates the YAML, and then applies that to the cluster by default. So in this case, to integrate Vault, what we use is something that is called the ArgoCD Vault plugin, which is a binary that you can get access to. And then we pipe the generated YAML through this plugin. And the generated YAML will contain these items. So this plugin knows how to identify these placeholders and replace them on the fly before applying.
All right. Yeah. So the values, wherever they are used inside the definitions, they will be basically interpolated there. So it's basically like on the fly replacement of placeholders. All right. Yeah. Thank you.
So it's not like the good thing about this, and these are there are multiple ways of managing sensitive data to Kubernetes. This is the way where basically you take it as sensitive data, not as actual secrets. So it's not like you need to create a Kubernetes secret. It's really what you would put in your YAML, be it customize or Helm. You just replace with placeholders that will then be fetched from external sources at apply time. And in this case, it's Vault, but it could be something else.
Yeah, I use a similar setup, but with Helm secrets. And I also use init container for that with Argo. But yeah, I was unsure how the Vault does it, but yeah, I think it's the same.
Yeah, similar. Yeah.
All right, thanks.
So the alternative to this would be something like SOPs, where you actually encrypt the values and you put the actual values in Git encrypted with some sort of shared key or encryption key. In that case, there is one benefit, which is the actual sensitive data, be it passwords or keys or whatever, are part of the commit ID. So if you change that, it actually triggers a change in the deployment. This is not the case here. Like if I go to Vault and I change the value, this value here, this will not automatically trigger a refresh of the application because there was no change in Git, basically. So there are ways to have hooks so that Vault calls back Argo and triggers a refresh, but this is not built in as such. This is a slightly different thing. The bad side of doing that is that basically every time you change a password, you would need to commit it, the encrypted version to Git, which if you want to rotate the secrets often can be problematic.
Yeah, actually Helm secrets that we use is a wrapper around SOPs. So it basically uses SOPs underneath. So we actually have the SOPs encrypted secrets in the repo.
Right. So that's the other model where we also had the previous getting started tutorial was actually doing that. The benefit of this is that we can consider having Vault auto-rotating the secrets and pinging the service to refresh, which is a bit harder to do when you're committing the encrypted data to the repos.
All right.
Yeah, that's a good question. Thanks for raising. All right, so in this case, we also use a pattern called apps of apps. And you can see here that we have this apps app that basically is creating a bunch of application sets. And the difference between, by default, ArgoCD will have applications. The difference with application sets is that instead of having a single application, you have a template for an application that can be applied to multiple clusters. And this is what we were looking at before here, which is if I look here, I'm telling basically application set, and there's the template for the normal application, but then there's some placeholders that are basically the clusters in this case that where I want to run this. So I say I want to run this ArgoCD in any cluster that has the central true label. And the same for the ML, things can be seen the same way. The potential here is also to have labels like staging. If you want to have like staging and production clusters, you could add labels here, and you could have slightly different configurations or applications going to the staging and the production environments. For example, you could explore this here. Any label that you add here is also available in the template. So in this case, we can see that we only have one instance of each service running in one of the clusters, but actually for the add-ons, because we want to run the add-on on every cluster. In this case, we have 2 clusters registered. So both of them have the add-on, and we can see this in here. You can see that we have the 2 cluster registered, and we are putting the labels in Git itself. So if you go to clusters, they have this ArgoCD labels. So they both have the mon equals true, which means they are getting this add-on. And you can see the same here in the Argo. That's not what I want to do. If I go here, you can see that there's 2 labels that are ML and mon in this case. So you can edit you can edit directly here, but then when Argo would rerun, it would basically reapply these labels with the workflow that we have. Then for the clusters, we can see them here. So basically it's all the clusters. This cluster application is basically creating these workflows that are creating the clusters. And I'll show you how this works by looking at one of the clusters that I've created before. If we look at this one, you can see the steps that it's doing. So the first one is to create the actual cluster, and you can navigate here. In this case, okay, it's just checking. It already existed, so it skips creation. So I'll show you another one later. But you can see that it's first creating, then resizing, creating the node group, resizing. And basically, there is a trick here, which is where the magic happens, which is when you change the YAML, the name of the workflow will take the checksum of the content of the YAML for the cluster. So if you change anything, it will actually re-trigger a new workflow. And because I'm quite proud of this thing, I can show you here. Basically, it's basically doing a checksum of the content, which means it's actually triggering a new workflow every time you change the YAML. So it does an update on the cluster. So that's a nice trick. Again, as Diana said, there are better solutions, things like crossplane. Once we have a provider for our infrastructure, we can rely on that. This is just a temporary solution. And you can see it's a bit complicated, but again, it's all hidden. It's hidden complexity. In reality, all you care about is this YAML. Okay, and then we have all the applications that we talked about. So in addition to this top 2, and then you can actually filter them per area. So if I want to see only the ML applications, I can see just here, they have a label called ML. If I want to see all the services, then I filter by service, and you can see the 3 that we mentioned, the core ones plus the ML app that we are running here. Yeah, you can imagine how to explore these labels in general. The other thing that I wanted to show is that Argo gives you quite a lot of feedback on the status of the application. So a normal application will be that is fully deployed. You will see it as fully deployed here, and it says it's synced. You can trigger a refresh, which is basically checking for updates. And if there would be a need for a sync because the committee ID changed, then you can trigger sync. In this application, we're actually doing this automatically. So by default, Argo will refresh, will check every 3 minutes. You can change this. You can even configure hooks to talk for something like GitLab to talk back to Argo. But by default, it's 3 minutes. You can also reduce that value. And the other one that I wanted to show is that in this case, in the add-ons, you can see that it says synced, but it says progressing, and it says synced failed. And Argo actually gives you quite a lot of feedback on what's wrong. In this case, it's complaining that a CRD, which is this CRD it says too long, must have at most 262 kilobytes. So this is actually due to the way Argo applies things. It does kubectl apply, and this takes a dump of the YAML of the application, puts it all in an annotation, and there's a maximum size for this annotation. So actually, this is a problem more with the actual Prometheus stack that we are depending on here, and the way it's generating too much data. So a fix for this is separating the CRDs from the rest, but I just wanted to keep it so that I can show also when the syncs fail. Basically, that's the overview of Argo quickly. In the next steps, I will basically try to do some changes. So the way this would typically work is if we go back to our repo here. Sorry. So we have our repo. Then the way this would work is that in our team, someone will propose a change. So for example, say someone added a cluster and we want to add a cluster to our infrastructure. So in this case, I created a merge request. We can go here. Someone would review it. Does it look okay? Is it the right version? Are we using the flavors we want? And does it have the labels appropriate for that application? So if you're happy with it, then review, approve. And this gets merged, which means it's now in Git. So if I go to clusters and I trigger a refresh, we'll see that it immediately detected that there's something new. So it launched a new workflow. And this workflow is basically creating the cluster. So if I go to workflows, I can see now that there's a new workflow running, and the workflow is basically creating a new cluster. So if I go here and I check the logs, I can see that the cluster in this case did not exist, so it's triggering a new cluster. So creating a cluster takes like 5 minutes, but I can see here, if I show you also the list here, that we'll have a new cluster called 004. So it's creating progress. Again, like all I did was merge, and all the infrastructure Argo plus the workflows is now managing the clusters as well as code. Now, this takes a couple of minutes. So what I will do is I will go to another merge request that I have here, which is cluster 3. And you can see that I actually already created cluster 3 in advance to speed up the process. Okay, it has a merge conflict, so we'll just fix this. Yeah, proper conflicts, and this is a full Steam review. And where is it? Right, this one. In this case, we are adding 3. All right. This should be better now. You review it, and I screwed up. I needed to, so this is really a perfect demo. What we want is this. Pick the 4. So this is better now. Okay, this looks better. So we are adding a 3rd cluster here. The template is good, so let's do it. I will merge it. It's merged, so if I refresh again, it will hopefully create a new workflow here. Yep, so we should have it running here, and we see the 3, it's this one. Yep, and if I go again to workflows, we should see a new one here that is creating the new cluster. In this case, the cluster exists. So it says exists, it goes to the next step. It will try to resize it next. Yeah, so the next step is resize. And again, it has the right size, so it just follows. And basically that's all it does. The next step is to register the cluster. So this is where things get interesting, is that in addition to creating local clusters, we are actually at the end of the workflow, we are registering the clusters automatically in Argo. There's a lot of things happening here, but basically it should have worked here. You can see also that it's setting some DNS aliases. The reason for this is for Thanos to work properly. So there's some plumbing needed here. But in principle, what should happen is that our cluster is done. And you remember before we had 2 clusters, and now we have the 3rd one there. So it just got added. And again, it got the labels that we added. So basically just by merging our code, we got a new cluster, everything is up and running. And in addition to that, we have a new application just deployed for ML in this new cluster. So if I go now, before I filtered by ML and we only had 1 instance of my application running, by just adding a cluster like this and putting the right label, we just got a new application deployed, a new instance of my application deployed in a separate cluster. So all of this becomes really like super easy to manage just with a couple of lines of YAML. And there's really nice separation of concerns between the people managing the infrastructure and the people managing the applications. So basically, that's the demo for the apps. I'll remove this. I will just check the workflows, but it might take still a couple of minutes here. All right. While we wait for this, the other thing that Jenna mentioned was the monitoring. So for the monitoring, we are relying on Thanos. The way Thanos is being done is that on every cluster we are deploying, and if we go here to the workflow, the last step in the registration is registering in Argo, but is also setting up these 2 DNSs. And you can see here that there's some sort of pattern where we call the name of the cluster and then Thanos sidecar and another one for Prometheus. And these are basically the endpoints we need for Thanos to be able to contact the remote Prometheus and scrape the metrics from the clusters. The way this is being done is that in our Thanos deployment, and if we go to the central one, there is a component that is a cron job that basically every minute is updating the query endpoints. And you can see here that it just triggered 1, so that's perfect timing. So it just triggered 1. Every minute is looking for new endpoints, and the way it's doing it is by looking at the clusters and choosing all the clusters that should be scraped with the appropriate labels and adding those as target for scraping. So if we look at the Thanos, I should have shown Okay, so you see here that before I refresh this, there were 2 target endpoints, but because we have just added the cluster, if I refresh this, you see a 3rd one. So this is also automatic. So we got a new endpoint being added to Thanos, which means that our central Prometheus, in this case for this demo, just got a new endpoint automatically, and now it's scraping the metrics from that cluster. So if we go to the central Grafana, we can see here actually the data from all the clusters. So you can see that the central clusters are running like Vault. The central cluster is running workflows, Vault, Thanos, ArgoCD, but then you can see that there are some metrics from ML as well. Probably need to refresh here. But you can see here ML as a namespace as well. So we actually get the full monitoring for all the clusters we own in this case. There is a way in this dashboard, we are not doing it, but one of the metrics one of the labels in the metrics is the cluster name. So you can actually filter then by cluster. If you put as labels to the clusters, so it's something we don't do in the demo, but we probably should update the demo to do it, is that if I go here and I go to clusters values, so in here, you can actually add additional labels like the region. I don't know, if you have multiple clouds, you could add a cloud, and then you can filter the statistics by those. You can filter by cluster, by region, by whatever metric you decide to use here, which is kind of handy. Let's see if the other one, there you go. So the other one also worked. So I should have a new cluster here. There we go. So we should have our cluster number 4 done. There you go, create complete, which means this workflow is done, which was this one, 4, yeah, cluster 4. So you can see that it also registered the cluster, which means if I go here to clusters again, I see a new one. And again, this is running an ML application. So if I filter by ML, I now have 3 instances of my application with the last cluster being added. It's still syncing, so it's just about to finish deployment here. It's not done yet. And if I go to the sidecars again in Thanos, this can take a minute because it needs to run this cron job. So let's wait just a couple of seconds here. No, okay, yeah. So you will see it. That's what I wanted to highlight here. So you will see here once that cron job runs, but you remember that. So you remember that the last step was adding this DNS alias here. So this one here. So basically, this needs to be propagated to DNS. So this is the step where the monitoring will only, the data from each Prometheus will only be collected every once the DNS has been propagated. So at CERN, this can take something like 12 minutes or something. So this, we won't get the data from this cluster immediately. It will take a couple of minutes for it to start being shown. But let's see if this is appearing here. This should run.
But it will not appear until DNS is
right.
added.
Yeah, because it cannot reach it.
It will try, but yeah, it will error.
So if we get a couple of questions, we'll eventually go back and show it. Let me check here if I missed something, because I have a list of things that I wanted to show, but I think that's pretty much it. So this is like a quick overview of what's possible, but the core thing here was that like a lot of people are using Argo to manage the automated management of the applications. What we wanted to show here is really the possibilities that are also there from automating the clusters themselves as well. And that's it for the demo. So we're more than happy to take questions. Feel free to come in. Do you have any final slide, Diana, or don't remember?
No, I don't.
All right.
I can scrape a thank you slide very fast. I think we have a question.
Yep.
Yeah, I don't have a question. Basically, I'm starting to use Terraform to basically describe the infrastructure of the infrastructure as a code of our systems. So we can have a person control it, and we can easily provision clusters based on the code. And as you show with ArgoCD, basically you can do the same, but following a GitOps concept, meaning that the things that are merged are automatically propagated to the cloud. But I'm just questioning myself because I'm new into this, and which is the main advantage of ArgoCD, and if I should keep trying to investigate the way of using Terraform for our infrastructure, taking into account that it's a very static infrastructure, as we don't really need to create many clusters on the fly. So what I've seen is that for me, for our use case, maybe Terraform is more or less the way to go. And here for ArgoCD is when you really need to create clusters on the fly, and you need to do like a lot of cloud operations, as you might be doing in your team.
Right. So I think that from then I can add something, but I would say there's two parts. One is that we use ArgoCD for everything. So for applications, so for deploying applications, and every time we reconfigure an application, we are doing it with ArgoCD. So this is the core use case that we've been doing until now. It's not just about clusters. Like if I and I could do a demo, like I had this.
I'm more talking about the cluster part, not the applications, because I know that you're using GitOps for the application things to configure everything, but more for the cluster thing. It's mainly to just apply the same concept of GitOps to the cluster, to the infrastructure part, right?
Yes. So the reason that there's a couple of reasons why you would consider it, but I wouldn't say like if you're using Terraform does a good job. There are a couple of differences, is because right now we are using these workflows. It's kind of a hacky way to implement this. Eventually, we'll use something like Crossplane, and the Crossplane OpenStack provider is actually relying on the Terraform module for OpenStack, but what it gives you is the notion of a resource. So meaning that a cluster becomes a resource in Kubernetes. So every time you change it, like it will be applied. You don't have to rerun Terraform to apply everything that should be applied. It actually becomes a resource in Kubernetes, which means you can immediately manage it with Argo. So the clusters would appear here as clusters, which means then that you can do this assignment of what goes where, and especially when you're managing upgrades, you can add a cluster and just put the flags when you're ready to have the new instance there without having to do any kind of extra manual operation. Then it depends how you're using Terraform, but I would say the main thing is that everything becomes a Kubernetes resource, which means you can have a central place where you manage everything, both applications and the infrastructure. You know, Diana wanted to say something. So
it's just the initial question was kind of like Terraform versus ArgoCD, but it's probably more Terraform versus Argo workflows to provision clusters. And I think Terraform is actually perfectly fine for their use case, but it can be used with ArgoCD to create an even better solution.
Yeah. So one thing I wanted to show is this. So this is basically what we will move to, which is the provider OpenStack of Crossplane, if this works properly. Because in the end, what this allows you is to, underneath it's using Terraform, but basically when you deploy it, then creating a cluster becomes like a cluster resource. Like you have a deployment, it becomes a cluster resource in Kubernetes. So all this complexity that we have today with having to have workflows becomes much simpler because the core thing of managing clusters goes away. Does this answer your question, Paul?
Yes. Thank you so much.
Yeah. Just realized I see hands raised here. I don't see if anyone.
I have
go
one more question. Yeah, so with app of apps, I'm also planning to, or actually I'm implementing it already, and I want to bootstrap ArgoCD and then manage ArgoCD with itself. When you do that, is ArgoCD deployed through application replacing the original ArgoCD installation, or is it running in parallel for some time and then you kill the ArgoCD instance that was used for bootstrapping?
You can answer if you want, Diana.
It picks up the existing resources that are running. It doesn't kill them. It just understands that, okay, this is running, this is what I need, and I will report as being healthy. Unless you have a conflict somewhere, and it will show unhealthy, but it just works.
Right, so it replaces resources if needed, and it doesn't create copies of it, basically.
Yeah, if what it needs is already running, it will not recreate.
Okay, and this matching is based on labels, or is it based on resource names, or both, or how does ArgoCD know that it shouldn't recreate the resource, but basically it already finds the existing resource? This is based on labels or something else?
I think it's everything, almost.
Yeah, so the answer to that is that Argo generates the YAML of the full thing. And to match the differences, it takes the YAML it generates with the existing YAML in the cluster and does a diff. So unless you have changed something, all the like resource IDs and things like this, it ignores. So basically, if the YAMLs match, it's not going to touch anything and just says everything is synced.
And an interesting thing we discovered with Ricardo recently is that ArgoCD doesn't put an annotation or a special label to say, this is what I deployed. So if it's kubectl apply or ArgoCD did apply, you will never know actually who created the initial resource.
And this is not the case for example, Helm. Helm is kind of explicit about, I created this, and we can take an example here.
Managed by Helm, right?
Exactly.
Like that.
So if we go here, you can see here that it adds its own annotations, or yeah, no, this is not a Helm application, sorry. So let's do one that is managed by Helm, this one. Yeah. It should be here. This one is definitely managed by Helm. Okay, but yeah, you will have to trust me. For some reason, I don't find it here, but there is definitely like a managed by Helm, and it even has like the application name, the Helm application name, and things like this.
But the thing is, if you do Helm install for ArgoCD, it will have these annotations, what is managed by Helm. But when you do Helm template, it will also have them. So you don't have a conflict here as well. It will be the same.
And if ArgoCD application has additional resources, they will be simply created as well, right? Because they will be not in the original bootstrapping ArgoCD instance, but then when
I would advise them to be though. You should have a Helm chart stored somewhere. You're deploying it manually, and then you give the same Helm chart to the ArgoCD application. Because if you're changing things, you might have a conflict that you'll have to track. So
right.
what we're doing here, yeah, sorry.
So what if, for example, I have secrets that I want to apply only after bootstrapping the ArgoCD, and I want to manage them with ArgoCD. For example, I wanted to implement or integrate single sign-on for ArgoCD, and there is a client secret for the application, basically. And I want it to be part of ArgoCD rollout deployment, but I want it to be installed only after the bootstrapping phase. So then I have ArgoCD application, which contains everything that I had in the bootstrapping instance, plus, for example, another secret containing some additional data. So how I should, in this case, for example, manage that? Create it as a separate application later on, or how would you do it, for example?
Yeah, so I can try that one. So there's two ways to do that. Either you enable SSO from the start. So this is actually what we did in our actual ArgoCD instance that we use for our services. So what we did is we installed with all the SSO secrets, but we never committed those secrets. We basically did what we are doing here, and Helm install by passing an additional values file that has the configuration for SSO. Once it's running and it's connected to Vault, wherever Vault is, if it's yours or an external, then you can commit in the actual configuration, you can commit the placeholders, and you could already have them there, and you don't pass the additional values file. And because it's already there and it has the plugin to talk to Vault, actually, when it gets onboarded, it will just work. Because right here, there's no Argo running. Once you have it running, Argo is not an application in Argo yet, but it can already talk to Vault, so it's ready to be onboarded. So this is kind of, that's why this is called Bootstrap, because there's like a couple of manual steps to set up this initial service. But once you have done the onboarding of Argo, linked to Vault, then it just works. The other option is to have at the beginning Argo not using SSO, just using a token to manage that until you have everything ready, and then you change you onboard the application still without an SSO, and then you change the configuration to use SSO since it can already talk to Vault. But doesn't really make a difference. Both will work.
Okay. All right. Thank you.
I'll be brave and try here. I think it takes a couple of minutes and still not there. All right. Any other questions? Yeah, go for it.
Actually, I have another one about SSO. As far as I know, in OIDC tokens, at least the one issued from the CERN provider, there is no groups claims. Do you do some magic there, like for example, mapping CERN roles to groups or something similar?
Yep.
Okay.
So I don't think we have the example here. I commented it out, the SSO configuration, but let me check here what we have. Okay, so it's commented out for the demo. We don't do SSO, but basically this is what you would need. You can see here that it's asking for the CERN roles, and then you can have this policy that says which role maps to which policy that you're defining. So we have an example here if you need, and you also have here the example for the configuration. And yeah, you will need the ingress as well once you do SSO, of course. I've also let's encrypt with traffic.
But for that, do you use DEX or do you use the Keycloak provider?
We go directly to the CERN Keycloak. You mean for IDC?
Yes, for IDC, as far as I know, you can either use DEX, which in ArgoCD, you can either use DEX and it allows you for like greater flexibility, like for example, mapping custom claims to standard claims, or you can, for example, use Keycloak provider, which is a bit simpler. But as far as I know, with our OIDC configuration at CERN, it doesn't work because of that group's claim that is missing by default from OIDC token.
As you can see, where DEX enabled is actually false. We're not using DEX, not in the demo, not in our actual ArgoCD instance.
Yeah.
Okay.
And you don't need it. Like you don't need to. You can use the. I think it's. I'm trying to remember how it's called. I think it's generic. It was called something like that. I would need to check the documentation. But if you go to the OIDC part, where it was. This is also a bit complicated. This. Let me see if I search. I should find it here. Yeah, so there's some sort of existing IDC provider. I think that's it. This is the one we are using, and you can say it can use generic OIDC IDPs. This is what we are using. We are not using the specific provider for Keycloak or for DEX. We are just using the generic one.
Okay. Okay. Thanks.
right. Any other questions? There's always something that breaks. So actually this bit, there's something stuck here on syncing, which is this, trying to deploy a second one. Okay, I'll search for it. All right.
Is Vatan's sidecar there?
Yeah, I'll debug it after. I'll accept one failure in the many demos. It's fine. Yeah, it's something is missing here. Okay. I think we just passed 1 hour or reached 1 hour. So unless there are other questions, I suggest we close here. Again, like if you want to play with it, go to the repo here. So it's GitLab cern.ch, Kubernetes Automation 101 ArgoCD. We might be changing it as we go, especially regarding the documentation. The goal is to replace eventually the workflows for cluster management with Crossplane and try it out. But it should have quite a lot of information if you want to try Argo yourself, be it for applications or for both applications and clusters. So give it a go. Any kind of feedback, we're more than happy to get it and try to help out as much as we can. So thank you very much. Do you want to add something, Diana?
Thank you very much for joining. This is a work in progress, and we will be very happy to get your feedback and try to debug with you if something is not working.
Thank you. Bye-bye.
Bye-bye.
Thank you.
Thanks a lot. Bye.